Welcome to Honors Geometry, Lesson 5.4, where we talk about the medians and altitudes of a triangle and what happens to those medians. I think you can figure out what an altitude is, but why don't we figure out what a median is? Alright, here's the median of a triangle. A median of a triangle is a segment drawn from the vertex down here to the midpoint of the opposite side. That is what a median is. Okay, there's the definition. I know. Where is it? Here comes the theorem. The Centroid Theorem. The medians of a triangle are concurrent. That is, they intersect all at the same point. That point of concurrency is called a centroid. The centroid will divide each median into two parts. The bigger part is twice the length of the shorter part. Okay, now that you got that written down, let's take a look, see. Alright, BZ is median because Z is the midpoint of AC. AY is median because Y is the midpoint of BC. And CX is median because X is the midpoint of side AB. So median BZ is cut into two parts. BM is twice as big as MZ. Median AY has been cut into two parts. AM is twice as big as MY. CX has been cut into two parts. CM being twice as big as MX. Now, in your book, it will say that the median is cut into two parts. This part is 1/3 of the whole thing, and AM is 2/3 of the whole median. And that's basically what I just said, that this one is twice as big as that one. So this is 1/3, that's 2/3. Alright, let's see how this theorem is put into practice with some numbers. Are you ready? Tough luck if you're not. Alright, let's see if I can get my handy dandy pen out and we'll do some writing. Alright, if BM is 8, how big is MZ? BM is twice as big, that would be 4, yes. How big is BZ? You betcha, 12. Okay, how about if MZ is 8? How big is BM? Good, 16. And how big is BZ? The whole thing, 24. How about if I tell you the whole thing is 15? Okay, MZ is going to be 1/3 of that, 5. BM is going to be twice that, 10. 10 plus 5, 15. Okay, CM is 42. How big is MX? Okay, CM is twice as big as MX. That would be 21. And the whole median, 63. And that's how we'll play with centroid M, and how a median is cut up into two pieces. Oh, by the way, the centroid M, that's also the balance point for that triangle. So if I tried to balance that triangle on one point, I'd put it right at M and it should balance. Alright. Section was medians and altitudes. Let's go ahead and see what an altitude is just to make sure. An altitude is a segment drawn from a vertex right here down perpendicular to the opposite side. That's an altitude. Okay, there's a definition. Here comes a theorem. It's a pretty simple theorem. The altitudes or extensions of altitudes of a triangle are concurrent. Concurrent means that they meet at the same point. That point of concurrency is called the orthocenter. So, from this vertex, drop an altitude down perpendicular to this side, but we got to extend that side in order to do it. There is the altitude drawn to that side. Draw a perpendicular to the opposite side right here. We have to extend the side. There's the perpendicular drawn. And then the altitude drawn from this vertex to the opposite side looks like it's going to be about right there. And notice that those three altitudes, when I extend them, all meet at this point right here, which is called the orthocenter. Alright, I think I've got one more screen for you. Alright, so let us review. The perpendicular bisectors they meet at the circumcenter, and they are equidistant from the vertices. The angle bisectors, yeah, this should be, they meet at the incenter, and they are equidistant from the sides. The medians, they meet at the centroid, and the centroid cuts each median into two parts. The bigger is twice the smaller. And the second thing is, it is the balance point. That centroid is the balance point. So the altitudes, they meet at the orthocenter. And because I think the centroid has two special points, the orthocenter doesn't have anything extra special other than it's a point of concurrency. That concludes all the points of concurrency, as well as this concludes Honors Geometry Lesson 5.4.